today. Yes. Our meeting today is a workshop on beginning C++. Yes. And yeah, so maybe before I introduce the topic, let me just say something small about women in engineering. So, women in engineering is a society in Kenyatta University. It's not just for women, rather it is for everyone. Both, as long as you're a member of IEEE, it is free. It's free. You can join it. You can join it whether you're a guy, you're a guy or a lady. Yeah, it's free for everyone. So we is a global network of IEEE members and volunteers dedicated to promoting women engineers and scientists. And also, it inspires us with the academic interest in a career in engineering and science. So one of the objectives of we is to organize major technical conference to enhance networking and promote leadership. Another is also to mentor young girls in high school, STEM. Yes. So aside from that, now I'll just go ahead and introduce the topic today, tell you about C++, and then introduce the speaker. So, give me a minute. So C++ was developed by Brian Strauss. Yeah, it was developed as an extension of C language, and one of the objective of our meeting today is, if you if you want to know more about C++, maybe you wanted to begin you've been thinking of starting the C++, and now this is a chance for you to learn. Or maybe you began and somehow you got stuck. This is the opportunity for you to know, for things to be cleared out. Are you going to have a clear concept of what C++ is, how to go about it, and how uh, um, how it can be easier for you to continue learning it plus. So, no, ask yourself is why I use plus. So, the reasons why you can use plus is it can be today's open space embedded system. Also, C++ is an object that allows code to use learning developing cluster. It's flexible and can be used to develop adapted to multiple platforms. All is easy and fun to learn. As that is it. And now I'm not going to introduce our speaker today. So our speaker today, his name is Alan Koech. Alan Koech is the current chair of IEEE Kenyatta University branch. Is also the chair of Photonics Society KU. Aside from that, Alan Koech is a bioengineering student in KU. Also, he is the 20 UN Person of the Year and co-founder and CEO. Without time, now I'm just going to allow Dan to take over the meeting and clarify in case you have questions or you want to ask any question, just feel free to chat on the chat box. Just type your question on the chat box and then we'll get them answered. So welcome.
Thank you so much, Masi. Hope I'm audible. Just let me confirm if you can hear me. Just say you can hear me. Okay, perfect. So as Marcia said, my name is Alan, and I'm going to take you through this session today. It's a workshop, so I'll kind of first begin with some. Let me try to share my screen. So I'll kind of try. Just a moment. Yeah, I hope you can now see my screen. So I'm going to first to go over one or two things about C++. I'll first take you through the theory. So at least when you're doing some hands-on, at least you have the basic knowledge of all these concepts that you're going to cover today. So as the title suggests, this is going to be a series of workshops, this being the first one. And the reason for this is that we don't saturate you on your first day with a lot of heavy terms, some big terms or some heavy content, because we are assuming that we are all beginners. Of course, there are some people who are already advanced on this. Um, on this. So today we'll just take you through an in-depth explanation of the C++ basics, as well as tell you where it's being used, as well as some of the companies that actually do use C++ in production. Many of them, we know them. So I'll just mention a few. As you know, C++ is one of the best languages to know because having knowledge in C++ will give you easier time as you transition to other languages like C or even higher level languages like Python. So this is just being, it will be a refresher course for those who have learned C++ before or C before, because you'll find a lot of similarities between C++ and C. So as Masi has mentioned, my name is Alan, and he has already mentioned all this about me, so I'm just going to skip over it. Although one thing maybe I should add, I'm also a member of EMBS, which is Engineering in Medicine and Biology Society. I'm also a member of CAS, which is Circuits and Systems Society, a member of ComSoc, which is Communication Society. And before I finish it, I'm also a member of WE. I'm also in the WE Society, supporting the ladies in engineering. So what should we be covering today? Basically, we'll be looking at what is C++ and where is it used today. I've heard Masi talking about the history. Shall we again say one or two about the history of C++ and why it is what it is today, as well as go in depth about some concepts that will help us understand it more better. We'll also do some environmental setup, that is, I'll tell you how to run your code, where to run your code as well as mention some of the basic syntax about C++, because C++ is one of the languages that is very strict about syntax. So I also mentioned some of these syntax include things like headers, namespaces, comments, the return functions. I'll be measuring them in depth as we move the next stages. Also, shall be talking about the data types that store information inside your code. This can either be primitive data types or user-defined ones. We also looked at the variables and the variable scopes. Then we shall do some coding, which is usually the fun part. We test the knowledge on what you have covered today. So, Matthew already mentioned some of these things. So the big question is, what is C++? There are those of you, of course, who already have knowledge about what it is. But as I said earlier, we are beginning from a stage whereby we assume that we are all beginners. So let's all begin from one level. We go together to the next step together. So first, people normally tell you that there's something called a programming language. So the big question is, what's a programming language? So usually a programming language is a formal language which actually comprises a set of instructions that produces some various kinds of output. That means that it's just a programming language will encompass some instructions that you just invoke them using your own logic. to be able to achieve or get some specific output which you desire as the user. So therefore, just like languages, you have had languages like Python, C, JavaScript, Go, PHP, the list is endless, and they're all called programming languages. So just like those languages as well, you find that C++ is also a programming language. So the next point is that C++ is usually referred to a middle-level programming language, and I want to explain why. And in programming languages are usually categorized into three, that is the low-level programming languages, the middle level, and the high level. High-level languages include languages like Python, JavaScript, also Java, Perl, PHP. All these languages are usually high-level programming languages. So they're usually called high-level programming languages because they actually do provide almost everything that a programmer needs. Or initially, it's usually easy to learn them. So if you've ever had terms like these are scripting language. So most of the scripting languages are actually high-level programming languages. For the low-level programming languages, we have languages like assembly. I think that's one of the areas where we have very few languages. Assembly being, I think, I'm not sure, but I think it's the only one there. So low-level programming languages actually do provide only the access to machine-specific instruction set. That means that they do not provide any other functionality. Only the functionality provided supported by the particular architecture. So for instance, if you're running an Intel machine, Intel machines like Core i5, Core i3, Core i2, and the instruction set for machine like an ARM, like your mobile phone is running ARM, or a machine like RISC-V. So all these machines differ in their functionality. So assembly language for all these languages will differ. They will never be the same. So assembly language will only provide you the specific instruction set which is supported in that particular architecture. So then what's a middle-level programming language? So these are languages that lie actually in between the low level and the high level, in that they still provide you access to the low level instruction set, which is supported by the specific hardware. But as well, they add some layer of other functionalities that the low-level languages do not provide. So mostly you usually find here the C and C++ languages in this category. Although some books will tell you that actually that C and C++ are still high-level languages because they provide you with those abstraction layers as well as the high-level stuff. So C++ is also referred to as a general-purpose programming language. So the big question is, what is a general-purpose programming language? And the answer is usually that general-purpose programming languages are usually intended or designed for writing applications for a wide variety of needs. That means that you as the end user, you as the programmer, you as the coder, you're the one who will now decide the functionality you want to implement. It is not intended for some specific use. It's usually designed for use by any kind of, you decide the functionality you want to have. That's why it's called a general purpose programming language. And usually it's a compiled language, not interpreted. And I will be mentioning this later in this session. So Marcia also already mentioned some of these things. So I'm just going to mention about the companies. So C++ finds its application in many areas. The list is usually endless. Any area you want to think about, you find that C++ is also applied there. So issues like operating systems for the different different operating systems that we have currently. The big ones, the big four are actually Windows, which I think for those who use Windows 10, Windows 7, Windows servers, that's an operating system. Number two is actually Mac OS. That's what for Apple. Three, we have Linux operating system. And four, we have Android. We normally also call it an operating system. Although there are many other operating systems like the BSDs and many more. So almost all these operating systems use a combination of C and C++ to when they're being made. and we shall look at the reasons why later. But if you want to really see how such a system is being built using such languages, then I'll suggest you follow this link for Linux Torvalds. This is the Linux kernel that's being used currently. I'm running a Linux machine. My machine is running Linux, and this is the code that's actually running everything inside my machine. So if you want to see how these things are being implemented, you can be able to click this link. You'll be taken to GitHub. This is the GitHub page for Linux Torvalds. You can be able to see how the Linux kernel is being made using all these things. So one of the other areas which is very major is the browsers. For those of you who are following these sessions using your computers, you might find that you're using a browser to access this webinar or this workshop. So the browser has a lot of things to do. First, it has to fetch all this data that you're seeing. Two, it has to render them, and three, it has to do it has to actually monitor for any other events. So you find that if you've ever done some web programming, they usually tell you that JavaScript is a slow language. But you find that actually somehow you are getting almost real-time communication between me and you. So that is brought to you courtesy of C++, because most of the rendering engines for web browsers and all these things are actually written in C++. If not C++, you find them a combination of C and C++ because of the performance part. So you can be able to see an example here is the Chrome V8 engine. This is the engine that actually powers the Chromium browsers as well as the Chrome itself. This is actually being maintained by Google, the company itself. And actually, this is actually one of their websites, one of their GitHub repositories. So you can go to go there and see actually how they have structured their code. It's usually a bunch of C++ and their header files. Just see how all these things is being done behind the scenes. It's a very big, massive code base. So that's what actually does the rendering of the JavaScript files as well as the HTML files, which is being sent over to you. Three is about the main libraries in the current market that actually do employ C++. Some of them being the machine learning libraries, as well as the computer vision. One of the biggest misconceptions is that these libraries are written in Python, because most of us who have learned some computer vision or some machine learning basics usually do them in Python. If not Python, you find them in maybe JavaScript or maybe Java. But the truth of the matter is that all these libraries have been implemented in C and C++. Case example, TensorFlow, which is being maintained also by Google. It's an open source library, and you can go check it over on Google on GitHub. So most of this source is actually C and C++. Then there are now language bindings for Python, JavaScript, Java, all those things. The same case also applies to OpenCV. OpenCV is a computer vision library used for accessing cameras, manipulating images, manipulating video feeds. So all these things are being done behind the scenes by the C++. So you might be scripting the user part using Python or JavaScript or whichever the language you're using, but the heavy part is being done actually by a C++ part. Some of the common databases we use actually in the market, like database like MySQL, PostgreSQL, and many more. I think even MongoDB, which is an NoSQL database, all of them has been implemented in C++. So you're just getting language bindings for your specific programming language, which you are now currently using, maybe JavaScript or Python, C, C Sharp. So all those are just language bindings, but the real work is being done by a C++ code base. Some of the areas which you find application as well is embedded systems. For those who have done or who are doing, who wish to do electrical engineering, this is one of the areas which you will find interest in. Playing around with these different components like Arduino, STM32, Pico boards, joining them with sensors, try and make a system where they'll try and communicate, they send data over. So all these things, you find that most of them are actually being done in C++ or C if you like it. However, in the current market, you find that currently people are trying to adopt using Python for some of these cases. That's why we have something called Scikit Python, which is an implementation of embedded systems but using Python. Although it works well, but you find that for a case whereby you have limited memory, then you can't be able to run the Python interpreter inside those boards. So you have to go with C++ or C, which is still heavier. One of the other issues is C++ is used in making compilers, and I'll mention more about compilers later. So these are most languages that we use currently, like case example Python. Python has something called CPython. CPython is an implementation of Python, the interpreter itself, that actually does the heavy job. When you're running Python, it will interpret your code into the machine code that the machine can understand and execute your code. So the CPython has been implemented in actually C. Although we also have other languages that have their interpreters originally written in C++ and C, but later they were switched to their current languages. For instance, for Python, we still have something called Python PyPy. Yeah, it's a Python is the interpreter implementation in Python. So it is the same language being interpreted by the same language. But we still have the C Python, which is actually still the default library for Python. So C++ is still used in banking systems because of we need a lot of concurrency in such systems, as well as in medical devices because we need stability, accuracy, and speed. Because here is a matter of life and death. So why use C++? The biggest thing is usually about speed, because C++ is compiled down to the machine code. So that means the machine, during when you're running your programs, your machine just executes the code. It does not do any other thing like interpreting the code, type checking, like is this supposed to be an integer or something like that. It just executes the binary. So you find that it's very fast. And with the recent development in technology, you find that you can even do more optimization. The compiler itself will do some optimization for you to be able to harness the power of the current architecture you're running in. So number two is that C++ is usually close to hardware. C and C++ are very close to hardware. That's why you find they are heavily used in the embedded systems, whereby you can be able to manage your memory the way you want it. It gives you the freedom and the power to manage your memory. That means that when you're creating a variable, you are assigning a memory to that variable, and you still have you're the one who has the sole authority to deallocate. If you fail to deallocate, you find that you end up having other issues. Memory is just full, but your program is very small because you're not deallocating the memory. So C++ and C gives you that power to be able to control every piece of your hardware the way you want it to be. Number three is about concurrency support. Concurrency is basically trying to run multiple things at the same time. Now, when you go to things like banking systems, whereby you have more than 1,000 transactions going on in every second, then you don't want a language that will be kind of trying to figure out, is this a variable, is this variable an integer, is this a boolean? So you want something that you send it an instruction and it executes the way it is. That's why C++ and C is heavily used here. One other feature is that C++ is statically typed. And what do I mean by this? That statical type means that when you're writing your code, you specify the types, data types for each variable you're using. So if you have a variable, then you say that this variable is of this type, like in case maybe an integer, and you know integers occupy maybe 4 bytes. So with this comes the benefit of speed, and that's why you can be able to compile it as well. So C++ brings you all these benefits, and one of the biggest issues is actually its speed. So, but of course, learning C++ might be a bit slower than learning languages like Python, but in the long run, learning C++ will be benefit. It's also more beneficial than it will actually be more beneficial to you, because if you need to transition to Python, you'll have an easier time, as well as you can be able to integrate both C++ inside your Python code. That means you optimize for speed, but you still have time to maybe use the normally call it a bit slower Python. So So what is the history of C++? This is the guy. He has a very hard name. I think it's called Jan Strostrup. That name is very hard according to me. So this is the guy who came up with C++, and this was the time when he was working for his thesis. So he was using a language called Simula. It's actually a framework, I think so, for simulation. So during that time, this was one of the languages that was offering object-oriented programming, OOP. That means using issues like classes and objects. So this allows you to reuse your code more by just writing a template of a class and then being able to many objects from that class. So after he then created C++ it was initially called actually C with classes, or basically just a subset of C. And that's why actually is initially after in 1983 it was called C++. And for those of you who have done some C, you know that this plus plus operator here means incrementing. So in short, C++ is an superset of C, and like just call it a next version of C. So if you take a C code and you put inside a C++ file and you run it, it will run just fine because it's still a valid code. Although C++ has kind of tried to make libraries that conform to some of the C++ type checks as well as conventions, but still you can still use the legacy C code inside the C++ files. It works still well. You can still check the motivations behind formation of C++ by this guy. Is I think on YouTube. You can go to Google him, you'll find them. So because this is not an history class, let's skip the next part. So these are some of the terminologies I've been mentioning. I mean, you're hearing me say compilers. So basically, a compiler is just a program that actually does converts instructions into machine code or lower level form so that they can be executed by the machine. So back in the days, before we came up with these big languages, engineers used to code actually in binary. Even scientists used to write your code in binary form, that is using ones and zeros, and you feed it into a machine and it will compile your machine. It will run inside your machine. But the problem with that is that you need to know exactly each and every number, you know, their binary representation, each character, its binary representation. So it makes it harder to program, as well as if there's an error somewhere, then you have a very hard time trying to debug. So engineers try to become more clever, or let me say, become more lazier by they now came to the next step, which is called assembly language. So here people are trying to associate some commands in binary form to some English letters. For instance, moving by using the word MV or M or V to move data bytes from one register to another. But still, the problem with that was that, as I said earlier, for every architecture, the assembly language actually differs. So you need to know the assembly language of each and every platform to be able to compile for that platform. So as usual, we become more creative. We decided now to come up with languages like C, which are close to the low-level languages. So these languages compiles to the native machine code. So the only thing that you needed to do was that you needed to make a compiler for each architecture. For instance, if you're running Windows, you have had things like MSVC. If you're on Linux, you have had things like GCC. This is the GNU C compiler. So all these things have been written in the native architecture. That is, if you want to compile for Linux, you have to have a Linux machine. You have to compile in using a Linux. Although nowadays you can do emulation. You have cross compilers as well, which they compile for any architecture. So compilers, that's their basic work, just to convert your English written code into machine code. Assemblers mostly deal with assembly language, and their work is basically to convert the assembly language, the small tokens of English were written back to machine code. And then you have then the big man in town is called an interpreter. Most of the languages currently, the ones which are popping up as well as the ones we call them high-level languages, most of them are being interpreted. Because of example, Python, JavaScript, most of these are actually interpreted language. That means that when you're deploying your code or your application, it's just pure source code. It's not compiled at all. So that code is actually compiled at runtime. So when you're not running it now, the interpreter will now take your piece of code, interpret it to now the machine code, execute it. Take the next piece like that. And that's why people normally tell you that most of the interpreted languages are a bit slower than the compiled languages because of that small overhead of interpreting the code. So there's usually a very big war between compiled languages and interpreted languages. Although nowadays with advancement in computing power, you find that if you write your compiled language poorly, it will still have the same performance as a well-written interpreted language. So it all also boils down to you as a developer. How do you write your code? If you write a very clean code, then you find that it will run faster. You can even apply optimization onto it, and it will be very fast. So languages like C, C++, Go, Rust, all these are being compiled to machine code. And I mentioned that by Python, JS, PHP, they are just interpreted languages or scripting languages. However, there's something we call nowadays JIT, that's just-in-time compiler, which is trying to compile some of these scripting languages to machine code at runtime. So let's talk a bit about the environmental setup. You want to try writing your C++ code, you want to run it as well, or you already have a code and you're wondering like, how do I even run it? So there are very many things that you kind of require, or very few things depending on your level of expertise. So one of the biggest things that you require for you to be able to develop in C++ or any programming language is first a text editor. This will just allow you to type in your English words, that is your program. You type in, import the things, you write your code, you write your functions, you declare variables. But now that's not the end because you need to convert this source code now or you'll be able to run it. So with a text editor like Notepad++ in Windows, VS Code, which is cross-platform across all the platforms, we have Notepad as well. We have things. There are very many text editors. Some even use what do you call them? You can even use Windows. What is the name of this one? Word. Others even use Word. It's funny, yes, but it still works. Although some text editors have been specialized for writing code, like VS Code, which it has a lot of extensions which its purpose is just to help you in syntax highlighting, give you some suggestion on when you're typing, it'll give you some suggestion like maybe you meant this package or this word, and it helps you code faster. That's the good thing about it. So once you write your source code, the next thing you require is actually a compiler. If you're dealing with C++, you need a compiler. So this compiler will convert now your source code down into machine code. And some of the most common compilers, if you're running on Linux, is GCC, on Windows is MSVC. It's called Microsoft Visual Compiler, Visual C++ Compiler, something like that. I have MinGW, this is GCC, but on Windows. You have CLang, which is currently cross-platform, something like that. It's used mostly everywhere nowadays. So these compilers now will be able to convert your source code into specific machine code for your current platform. That means if you're running it on Mac, you'll get a binary for Mac. If you're running it on Windows, you'll find maybe an exe, that's an executable for Windows. Running on Linux, depending on the distro, you'll still get a binary for that particular Linux machine. But now, as a beginner, you find that you're trying to figure out the problem with having a compiler, having a text editor, is that you also have to know the commands to compile your own source code. And sometimes it gets a bit hectic if you start having a larger project. If you're having one file, that's okay, just be a one line command. But once you start having different files inside the project, it becomes a bit complex. So the best option for a beginner is that use an IDE. An IDE just stands for Integrated Development Environment, and this IDE just it has tools that has all the tools that the developer needs to be able to run and write their code. This includes things like text editors, a text editor which is inbuilt, a compiler which is inbuilt, a debugger, a linter, syntax highlighting, all those things. So it's just a single package that you can just be able to use once and run your code. So as a beginner, I'll advise you to use an IDE because it makes your work easier. Because as I said earlier, compilers have flags for compiling and optimizations, which you have to know to compile your files. But IDEs usually what they mask you, they do the hard work for you. Your work is just to write the code, add new files, press the run button. Behind the scenes, the compiler will make these long flags for compiling your code. And once it finishes compiling, it will just run your code, your binary file, the final binary files. So IDs are also good for managing your project or your files because as I said earlier, if your project grows, maybe you have 10 files, 10, 20 files, 30 files, you have to link all these files into one binary. And writing that command on terminal is a bit long and hard. You might end up even messing some few things. So I usually recommend if you want to, if you're a beginner, just stick to IDEs. Once you now want to do your own things, you've understood how the language works and everything, you can now go back to running them on the terminal using a compiler. So some of the common IDEs, we have of course Microsoft Visual Studio for Windows and for Windows. If you're running C++, it's just for Windows. Qt is one of the cross-platform IDEs. It's actually a C++ IDE, which is just not only just other purposes, but one of them is just you can be able to use it as a C++ IDE to run your code, write your code, and run your code. You have Dev C++ as well as the Eclipse C++ IDE. So there are tons of IDEs you can be able to use. These just a few of them. I'm not saying these are the only ones. And two, I'm not saying I'm recommending this. As a beginner, I'll talk about that later. But for now, these are some of the IDs which they are most common. If you just Google C++ IDs, you'll find as the top options. And then these are just the compilers I just mentioned earlier. GCC is for it's called GNU C++ compiler. LLVM is just the CLang for compiling C++ code. You can use any of them. If you use GCC, you don't need the other one. If you use this one, you don't need the other one because they kind of do the same thing. So let's now look at maybe you want to run our own code as a beginner for this exercise or for the next 1 hour, 2 hours, 3 hours. Setting up your environment can be a bit tedious. So since I'm guessing that some people or most people here are joining this workshop using their mobile phones, then installing an ID on mobile phones can be a bit tedious, and even the applications that we have on Play Store that can run your codes actually does that online. Usually type your code, but when you press the run button, it requires internet connection because it has to compile your code online. So for this session, then use an online IDE. This is the link. It's called onlinegdb.com/online_C++_compiler. So this is how it looks like. It will give you a very nice place for writing your C++ code. On top right here, you'll see that the language is C++. You can go to use it for many different kinds of languages, but for our case, you are going to stick with C++. This thing will offer you some very nice things like syntax highlighting, like you see how it's very colored. Two, it will offer you things like code completion as well as suggestions and things like that, which are very useful when you're learning because I like to type a command like where and it gives me some completion like maybe you meant this or this or this command. That's why I can be able to run faster. But now once I grasp all these things, maybe I'll now do away with the compiler and use a text editor now because yeah, that's a different stage now. So let me send this link to the chat section. Just a moment. Yeah. So if you wish to go as well into this website, you can do so. Let me send it. Yeah. So it's free, of course. So you can just copy the whole link and place it on your browser and run it. It will open for you an interface like this. Or let me show you exactly how it looks like. Yeah, here it is. So in between here, this is the code section where we'll be typing your code. Top here, we shall have the language selection. Of course, you have C. We don't have many variants of C++ because currently just click C++ and leave it at that. And on top here, to give you different buttons for running your code, you have the run, debug, stop. So maybe when you click yours, it will give you this left menu. If you want to be storing your codes there, you can sign in actually, sign up or log in to be storing your code. Then you can just be visiting there, logging back into your account, view your code, run it them, edit them. So this is kind of better because you don't have to have the hassle of installing compilers, installing an IDE, or yeah, things like that. So just simply just go online when you have internet connection and write your code there. So if you want to follow along, you can do that because this website does fine for both desktop computers and mobile phones. You can still access it. So let's now look at the basic syntax for our code. I think I've already seen that code, so here it is. Don't worry if the code looks a bit tough or something like that. We are going to look at each and every segment of it, make sure that you understand what it does. This is just a sample code to display hello world, because you know, for every programming language you go, the first thing you need to learn is hello world, how just to say hello world. And there's always that joy when you just run your first program in hello world. So I'm going to show you how you can do it. Then we shall advance later to other things. So this is the boilerplate code. That means that you'll be doing the same code, this kind of code in your projects over and over, and after some time you realize that it's just normal code. You don't have to cram them because they'll just stick into your mind naturally. So let's run this example online. I show you actually what's the output. I've just shown you the output here is hello world, but we never know. Let's run it online and see what we get. I hope you can see my GDB. So this is the code. Here we're saying hello world. I'm just going to run. I'm not going to explain the code first. So at least you see the output. I see they say down here that it's compiling, and here it is. The output is hello world. Maybe I can zoom in or not. Yeah, the output is hello world. So let's then break down this thing. We see what does each section stands for. And listen, explain to you so that you don't have to fear more about C++. So most C++ files end with .cpp or .cc. So whichever you find online or anywhere, they both refer to C++ files. Although you might also find things like .h or .hpp. Those are just header files for C++ files. So, but for now, we're not covering that. We're just going to look at the basic C++ file. So this is just the hello world example we've just run right now. And I'm going to take you through each section. So on your screen here, I've labeled the different sections with different numbers. And we shall be going through different numbers, explaining to you what's their purpose and how important are they. So the first one here, you're seeing this top part, which is I think color yellow, box of color yellow. So it starts with the forward slash with an asterisk and ends with the asterisk and a forward slash. So this one block, and it's usually called a comment, or if you refer to it as a multi-line comment, that means when you want to write different lines of comments, many lines of comments, you can just have them like this, open it like this, you write your comment, you close it. As well as number 4 here, this one here, with 2 forward slashes before it, then this is just a single line comment. So you might be wondering, so what's a comment? So comments are usually used to explain code, or you can still use them to prevent execution of some code when you're doing some testing. Maybe you don't want to execute maybe the printing of the hello world text here. You can just comment this line and it will not be executed. So all comments on your source code are not executed, are not compiled by the compiler, and therefore they're not executed. They're just there to help you, anyone reading your source code, to understand it. Or it's basically also a means of documenting your code, because you usually find that you write a code today, and when you come and read it 1 week later or even 1 month later, you're not even sure what you are writing there. So the best practice is that you document a code. And now, best way to document a code is to have comments where necessary or where applicable. But usually, you should comment as much as possible, because today you're the one managing the code, but you don't know tomorrow. Tomorrow it can be another person who has never seen your code. So make it easier for that person to come and see your code. At least you'll be able to see like, oh, this is a basic hello world example by, of course, me. And then also here, this says that this is a main function. So it's not like, oh, this is a basic hello world example. And then this part here, this is just a basic, just the main file, the endpoints of the application. So by having comments in your code, it makes it easier for other people to read through, follow through, because I can also follow a code and I advise you that this part, you can do it better like this. But if you don't document a code, I'll also have that time even trying to follow through. So as I mentioned, we have multi-line comments which can span multiple lines, like the number 1, and we have single line comments which just stays on one single line. Shall be able to see how we can be able to use them later when you'll be doing some coding. So number 2. Number 2 is just a preprocessor directive, which basically tells the compiler to insert the contents of this file here, the contents of this file called iStream, into your current project. So you find that you will not be writing single file projects. You might be having even 10,000 of files, or even 100, 10, 1,000. So there's a way you want to use a library called X inside your current project. And usually in other language, you say import those libraries into your project. And how you import those libraries into your project is by, in C++, you include them. So it has to start with the hash include, which is the preprocessor directive. And then anything in the angle bracket is now the library name. In this case, it's now a system library. Also, it's using the angle brackets. But later we shall look, under the advanced bits of this series, we shall look at how to make your own header libraries. So these libraries can either be the system, as I said, or user-defined, which you want to have inside your project. As I said, also your project can have multiple files which you want to use them inside your project, and the best way to have them is to include them using the hash include directive. And languages like Python, JavaScript use things like import. JS also has something called require. So they kind of do the same thing. If you're coming from those languages, you can be able to relate. Now let's look at the third thing called namespace. It depends. You might see some code not having this directive, because there are two syntax of having namespaces inside your code, and I'm going to show you when we shall be doing the example. So this is the namespace part which we're talking about, and basically take namespaces like a wrapper of some functions or identifiers of variables together, just something covering a bunch of them. So they're usually used to differentiate similar functions, classes, variables, etc. For instance, in C++, we have a library called Boost. Boost is one of the libraries that make very nice extensions to C++. And you find that sometimes they have similar, functions. Just example, maybe you want to instantiate a string. So the standard library has something called a string, and you also find that Boost also has a string. with of course additional, which has additional functionalities. So if you include the boost library inside your project, and you also have included the main standard library, so the compiler will be confused like which of these am I including, or which of these are you referring to? So the best way is usually to have these namespaces. For the standard library is usually std, this std here. For the libraries like boost, you'll have this, the using namespace boost, and I'll be showing you how to have, you can even have both of them in the same project, but I show you how to use them. So think of the, yeah, that's how it is. So another thing you should note about the line number 3 is that it ends with a semicolon. So all C++ statements ends with a semicolon. And like if you look at line number 3, line number 13, and also line number 15, all statements in C++ ends with a semicolon. Language like Python do not have semicolons, so if you're coming from there, you'll have a hard time because this has to have them. And if you go to line number 4, of course, I said it's still a comment. We just say that this is a main function. In box number 5 here, this is the box number 5 which I'm talking about. Now, this is the endpoint to your application. Think of it like a gate whereby everyone has to go through to be able to maybe access some few things, maybe access your home. So C++ has an entry point. If you go to Python, it also has an entry point, because think about this. Everyone writes their own code, their code in their own way. So the compiler has to know, or the system has to know, where do I start executing your code? So in C++ or in C files, you find that we usually have this int main function, and it's compulsory to have it, unless if it's not an executable. That's the only time when you can have a library. You can make a library whereby other people can go to import inside their own. So it doesn't need to have a main function, because the library that imports your code will have their own main function. They'll just be calling some function inside your code. So the main function is just like the gateway, as I said, whereby all execution begins. Everything above here is just preparing it, but now this is where execution begins. You can still have many functions on top of the main function, but your compiler, or maybe say the system executing your code, will be looking for the main function. And once the main function has finished executing, that's the end of your app. Your app exits. So you find that you normally call other things inside this main function. You can go to sleep the main function, things like that. So it's up to you now to do the logic. But the main function is usually the entry point. So let's look at now the return statement. Back here you see that there's a return 0, which ends with a semicolon, of course. And a return statement just basically means that the program is ending, actually. Let me just say like that. The 0 part at the end of it, the 0 code means that the program ran successfully, because any value of 0 means that the program was successful. Any value above 0 means that there was an error in your code, or there's an error executing some part of your code, so the program exited. And think of it like someone is calling a program. You've written your own program. I've written mine, but I don't want to include your project into mine. I want just to call it to do some functionality and get some feedback. So you see, I want to know if it was successful or failed. So this is one of the main things I'll be able to monitor. I'll be able to see what was the exit code, because return 0 just tells the compiler just to exit the code of 0. You find that other applications just say return -1, return 5, return 8, depending on now what happened in the code. So if I'm calling your let's say your program from my program, then I really want to know if it executed successfully or it failed. Because if it failed, what am I going to do? Am I going to retry, or am I going to tell the user there's an error here? Let's do like this. So that's the purpose of the return part. Return is very important, and you find that if you don't include it inside the C or sometimes the C++ files, you find that the compiler is very smart. It will add one for you. Although it's good to have it there, it's always good. It's kind of a norm. It's good to have it there. So there is one thing you also see in this Discord. We talk about the C out. So C out is just telling it is going to output this hello world onto the console or onto the standard output. So cout is basically telling it's a command which is part of the standard library, which is actually part of the. On top here, we did include an iStream library. So iStream basically stands for the IO part means the input output stream. So the cout is part of the output stream, whereby it will now output this string onto the standard output, be it a console, be it whichever you're using, be it it can even be writing to a file. So I'm going to pipe this output back to a file. So cout basically takes whatever you give it and takes it directly to the output. The end line part, this part is it's called the end line. It's just basically it adds a new line after the statement. So once you display hello world, you want to have a new line. So the end line part is what does that part. So this is there. Here is it. You can still use the new line character inside the word hello world to have a new line functionality. So before we talk about data types, I want to maybe come back here. Let's look a bit of what we've been talking about. So this is the include preprocessor directive to include a library. You can both include more libraries by just typing include. You see, it's very smart to suggest that you want to type include. The main libraries in the standard library, maybe I use the vector library. Not that one. Called vector. No, sorry. I'm missing caps vector. Yeah. Should not have this one. So you can go to have multiple includes inside your file. There's no problem. And this is the standard namespace I was talking about, which provides this. You find that if I do comment this line, I told you the comment start with single line comment start with these two forward slashes, and multi-line. Here's an example of a multi-line comment on the first part here. Starts with a forward slash and a star, ends with an asterisk and a forward slash. So you see that we ran this code and the output was hello world. So what about if we change this part to, let's say, hello all? What will happen? Of course, the standard output, the cout will take this string and, oh, sorry. Oh, yeah. We did comment the standard namespace, this one here. And now the compiler is kind of yelling, saying that cout was not defined or declared in this scope because cout is part of a namespace, which is the standard namespace. So you can either uncomment this line, or you can also you can go to use standard namespace like this here, and you can go just run this code just fine. So it execute just fine. Yeah, as you can see, hello all. So if you are having many namespaces inside the project, then the best way to use them is having the namespace name, then two full colons, and then now the name of the command itself. That way now you can be able to keep track of which namespace are you working with, because I might want some functionality from library X, and then I want to switch to a different functionality. So you can be able to switch them very fast using this syntax. Although let me just, for simplicity, let's stick with the original one. Yeah, like that. If you run this, still executes just well. So before we start diving deep into coding some few things, I want to mention two things. First, the data types we have in C++, and two is the keywords. These are very important. Once you understand those two things, you can be able to move into the next sessions very fast, because they are the basic building blocks for C++ programming. So data types comprised of two or more. We have the primitive data types, and you have the user-defined ones, like using type def. So primitive data types basically are basic data types offered by C++, which include things like the booleans, characters, integers, floating point, double floating point, valueless, wide character. So how you use them, booleans include things like true and false. Those are booleans, 1 or 0. For instance, is the light on, true or false, one of them. So that's the boolean. A character are things like a single letter. Think of it like, for instance, when you're talking about grading someone, someone's either having an A, a B, a C, or a D. That's a single character, and that's a character. So how you use them is plus plus use this part called keyword. This is a keyword for using the Boolean types. This is the character. This is an integer. An integer just from your primary school studies or whichever. These are just numbers, can be positive or negative along a number line, but they don't have decimal points. They are whole. They are what do you call them? There's no decimal points. So 0, 1, 2, 3, -5, -10, all those are just integers. And so these integers normally take up around 4 bytes of space inside your memory. Although you can have short integers, unsigned integers, long integers. All those are just what do you call decorators or what? Just if you are trying to optimize your code for things like memory, you can be able to add those things like short, long, be able to have more storage or lesser storage. A float is just decimal points. You can be able to store decimal points like 3.4, 5.9. That's just a floating point data type. A double one is bigger than a floating point. I think it should take around 8 bytes. Yeah. Then you have the valueless type. For instance, if you are calling a function which does not return anything, you can call it void, that name of the function. This just basically tells compiler that this one returns nothing. And then you have the wide character. A character is just one single character, but you can have wide characters. So C++ still provide that. These are just the basic ones, but although you can be able to build your own data types using a command called typedef, type definition typedef. But for our current level, just stick with the basic ones because they work just fine. So we're going to see and use this more when we'll be dealing with the variables in the same next session. Um, let's see, because we want to do some coding and it's good when we have some understanding of how to make our own variables. So for instance, you want to make a variable, you want to declare a variable. How do you do it? You now got to understand what's a data type. Therefore, variables also have types, and those are just the data types we've been discussing, like booleans, character, int, for, float, double, wide char, and void. So we have variable definition and we have variable instantiation. Think of it like when you're defining something, you're just saying that I'm going to have this variable. When you're instantiating that, you're now saying that this variable will be holding this value. So basically, the first example you're seeing here is that data type variable name. That's how you declare, then it ends to semicolon. So you say like integer x, character v, float distance. It's just how you define a variable. If you want now to assign values to this variable you've defined, you just say x is equals to v is equals to a, like that. So this is how you define, this is how you instantiate. But still you can do that in a single line, just like int, you define and instantiate immediately. Like here, you just say int age is equals to 5. So in short, you are defining a variable called age, and then you're giving it a value of 5. So remember that in C++, you can't be able to manipulate a variable before you instantiate it. For instance, maybe here we have defined an integer called x. Maybe I want to add 5. So if I try and add 5 to an integer called x, it will give me an error saying that x has not been instantiated yet. So it does not know the value of x. Although if you define your variables globally, they have their default values, of course, but if they're local, you have to give them a value. Although for now, let's just stick to this syntax. We shall just define variables, instantiate the variables, then use the variables. So just basically, definition of variables just tells the compiler where and how much storage to allocate or to reserve for that particular variable. Then instantiation just gives the value to that variable. So if you try and instantiate a variable with a different type from which you have defined it, it will also give you an error. The compiler will just say no. This is not the value I was expecting. So as I said, you can still define and instantiate your variables from the same line. So let's then look at some. How do you now make your variables? How do you name them? There are some naming conventions that we need to use. Don't worry about the right part. Let's just focus on the left part here. So there's something called keywords. I mentioned keywords back there when we were looking at here when we're looking at the data types. I told that these are keywords. So keywords are just basically reserved words in C++. You're not allowed to use them for making your own variables, or for naming your own variables. That is. So keywords like I've shown you cout. Cout should be somewhere here. I'm not seeing it. Yeah, this should be somewhere here. I've said car. Here is it. So all these keywords here, this is not the full list actually. This is just a portion of the standard list of the keywords. So you can't have variable called else, because else will be interpreted by the compiler for being a different thing. So you're usually told you should not use these keywords to define any of the variables. That's section number one. Number two, variables can comprise of any letter, uppercase A to Z or lowercase a to Z, an underscore or numbers 0 to 9. So not in other. Other things like asterisks mean something different in C++. So you can't define a variable just say that it's called an asterisk because it will mean something different. Also, you should know that variables are case sensitive. So if you have a variable called let's say x, capital X and small x will have the two different variables. Also, you can't search a variable name with a number. It should either start with a letter, which is uppercase or lowercase, or an underscore. Hope you're okay with that. For those who come from other programming languages, of course, you think you already know this. I was just brushing over for those who are new in programming. Although there are many other keywords that are not listed here, which are recently added in the C++ 20 standard. Things like export, import, module, they are currently keywords which have been reserved in C++. I think I've talked so much. I think I've been talking for too long and I might have been losing some people. So why don't we do the fun part, the good part of it? So what we're going to do now, we're going to just write some few examples as well as do some basic arithmetics. Of course, that's where you normally start for this session. At least we get to understand what we've been talking about so far. So if you want to follow along, you have a machine or you have a phone, this way you can follow along. I mentioned earlier, I sent the link to the chat section. You have the online GDB compiler. And just open it. As I type it, just type it to see what also happened on your end. It's always fun learning by also trying, because before you find errors, you can ask. That way you can be able to say, no, you did wrong like this. So next time you'll be knowing that that's not the best way to do it. So let me switch to my compiler. And I want us to do it from I want to clear all this code. Of course, I've run this code before and you saw how it worked. So what I'm going to do, I'm going to select all the code and of course remove them. So as I mentioned earlier that we have comments. So the best way I usually advise people to start your code is start with a comment, explain who is writing this code, when was it written, what is the purpose for this code. That's the best way to start your code. Even if it's possible, write your name, your email, something like that. So at least next time if I'm trying to go through your code and I find difficulty, I can go to reach you out. Yeah, that's how I like doing it. So I want us to start this code from a clear state. Let's do together. Don't worry, if you want to follow this code later, I'll provide all this code. I'll have it in my GitHub repo, and then I'll share the repo. Once I finish this session, I'll just share my repository. Also on my repository, I've been able to write a detailed guide of if you want to use an IDE, I've put links there as well, which one to use. You can just, there are a couple of them, as well as just this user guide of where to start. So let me just try this. Maybe it's not sure. So as I said earlier, multi-line comments begin and end with this syntax. Although you can still have this thing on a single line, there's no mistake. So if I write here, hello, this would just be a single line comment, but using the same syntax. Although this, I can replace this with this and I just say hello. This is still a comment in C++. Both of them still work very well. So let me replace this by this. And I think I'm going to write here. Of course, as I said, this is a multi-line comment. So I'll just write, this is a multi-line comment. So you can be able to go to a new line and write anything you want. Let me just say it's a workshop 1 of 2021, sorry. So you can be able to write anything, describe your code, what does it do, and things like that. So earlier I showed that the first thing you need to do is maybe you have to include library that you require. So in this case, we're going to use the iStream library, something like that. So iStream library is part of the standard library STL, and it provides the functionality to be able to interact with the user, display the standard output of the user, as well as take inputs from the user. Like if the user is typing using their keyboard, I'm able to use this library called iStream to be able to get the keyboard values and maybe do something with those key inputs. So as I mentioned earlier, you can also import other libraries. You can have as many inputs as possible, many inputs. And this code I'm typing is a comment, so I'm just saying just a comment. So as you can still include other libraries like vector, yeah, vector. This thing is messing me. So let me just move the standard vector here. Yeah, you can still use it like that. So you can still have many, like include string. So whichever the library you want to use depends on what you are doing. Because any library you add here will have some impact on your code. Of course, it will add the size of your code. Because a library like iStream is very huge, very huge. So you sometimes people use somewhere like print the standard IO for C, still works. Then let's talk about now the namespace. So in our case, you're using, you just do using namespace on the second one, std, standard. Std just stands for standard, it's a standard library. And then what now I want to do, I want to now write the main function. So this is the entry point of the application, as I mentioned earlier. This is where execution of my code will begin. So let me just write a comment. I say this is the main function. This is the main function. Just do int main. Let me just do return 0. So as I mentioned earlier, that the return statement just basically tells the just gives that the program has exited with the code of 0. If I omit this as well, depending on the system you're running, it might just run fine because the compiler will be able to replace that thing back there. So sometimes you might forget it, sometimes it depends. So, but it's good to have it there so that at least people know your code exited well, something like that. So let's say now that want to display the hello world. Let's display. Let's display the hello world. So just do cout. Use the two, you call the left, the less than angled brackets, two of them. And then you just put what you want to do, you put them inside there, just do hello world. And then we shall end with a new line. This just basically just says add a new line after the hello world. And I'll show you an alternative to that. Let's run this. You see, just put in the hello world just like the other. So alternatively, you can remove this part and you can have \n. So this is It's called normally called white spaces. You have the space, you have the backslash n, backslash a, backslash. There are a couple of them. So they're usually, I never talked about them though. So this usually means that add a new line, backslash n. So if I run this as well, you see it still adds a new line. And how to know that is that I can add a new statement here and I say again, and you let me run this. Yeah, you see that it pushes the statement to a new line because of this thing here. Alternatively, you can be able to remove that part, add like this, add this end line. So this is how you can be able to put a couple of things onto this, pipe them onto the C out. Just write them, add another one, but it must end the semicolon, the last point. So if I run this, should be same output actually. Yeah, as I showed you earlier. So there's no difference. So let's just stick with our hello world example. Let me just put the new line. So we have talked about defining variables. So let's define some variables. So if you have any question in case, if I'm going too fast, you can just say, so let's say you want to define some variable. Let's say I've talked about age. So you can go to define your variables as age, let's say int, let me just call it x, let me just call that as well, mangoes, anything. So you see, this still works, this is still well, but sometimes you find that you might want to join these ones into one line. That still works. You can go to define them. If they share the same data type, you can just have them like this. And then you can go to instantiate them later. So what I'm going to do, I'm going to leave them like that. Then we are going to do now variable definition, instantiation. So now we can go to say like now, what is the age you want to give someone? Let's say, let's just give someone an arbitrary age of 30. Let's assign x because an integer. Let's do -5. Oh, sorry, it should be equals to -5. Then let's talk about mangoes. How many mangoes do I have? Let's say I have 10 mangoes. So that's how you now instantiate the variables. I think it's just similar to other languages. Although, as I mentioned earlier, you can still do define a variable and instantiate immediately. So I could simply again still do like this. I can still do is equals to 10 here, and I remove this line. So this still works out, still works well. So maybe you want to display these variables. You want to play them on the console. So what you just do out, and I'll do my age is less than. Then I want to print that statement. Then I also want to print my age. So as I said, you can just cascade these things. You want that those operator, that operator, and then you just write the term age the way it is. Of course, I want a new line after that, so I add another end line here. So if I run this, what you expect to see is that my age is less than that, and there it is. Hope you can see it. So we print the hello world, which was initially there, which is up here. Then you're also printing this one. So you can also still do arithmetic operations on these variables. Maybe I want to add 10 to this variable. I can still just put it like that and add 10. There's a reason why I'm doing like that because you understand how BODMAS works, brackets off. So what will be executed first is the value of the bracket, which is age plus 10, which is 30 plus, which is 40. Then now, once we have a value of 40, it's now streamed out into the standard output. So if I run this, I expect to see my age less than 40, which is still true where it is. So you can still as well add all these other variables onto the same line. I'm just showing you how to do displaying out the variables. If you want to display the variables you have, or you want to log them and maybe see what the values you have in your variables, this is how you can do them. So let me just return here. Oh, sorry. Let me just return here age. Then I'm going to do, and I have, let's do the mangoes. What are these? These are mangoes. And then let's just add a new line inside. Let's do here. Always don't forget the semicolons after every statement you have is very, very important. So if you forget them, the compiler is going to yell at you, and it's good for you to know that. Let's run this. Then I'm going to remove a semicolon. I show you actually what happens when you forget to put a semicolon there. So as you can see, my age is less than 30 and I have 10 mangoes. This is as exactly what we expected. So in case I forget, let's say I remove a semicolon somewhere there, and I run my code. Of course, I don't expect an output. Of course, you see, you have been told that they expect a semicolon before the word cout, and cout is here. That means I've forgotten a semicolon there. So if I now run this is now going to be very well. Let's now look at how we can be able to maybe, because I'm seeing we have spent 1.5 hours so far. So I want us to do some basic arithmetics. We define a variable, we assign it values, then we do some arithmetics, addition, subtraction, multiplication, also remainder. So the basic arithmetics we have in math. And then we shall also do some user input. We try and key in some values, we display them. So these are just the basics of C++. And once you understand how this is done, then in the future sessions, when you shall be doing the advanced stuff like functions, things like, what do you call them? Functions, we have loops, we have conditionals like if, else if, while, all those things. Then we shall be doing later structures and classes. If you understand these things well, then once we will be on that level, then we'll have easier time, because data types is one of the areas where if you don't understand it well, then you'll have a hard time when you'll be doing future sessions. So let's look at let's define a variable. Let's do some arithmetics. So let's say an int of m. Let's assign it a value of 5. For the same line, I'm just going to do another int of, let's say, n. Let's assign it a value of, let's say, 8. And so let's do addition, of course. So I'm just going to print the summation of the values. And I just did the sum. So the sum of these two numbers, which is m and n, let me just do it like this. M plus n, n is, then I'll do my m plus n. Then I also do a new line. So executing this, just what to expect is that we shall get the summation of the two values. Of course, that's the expected. Oh, sorry, what have I done? Oh, sorry. I'm sorry, I've done, this is not supposed to be here. Yeah. So let's run this again. So as you can see, summation of 8 and 5 is of course 13. You can still do subtraction and do minus there and do a minus there. So what we expect is a negative number, which is negative 3, which is still okay. We can still do division, which is m over n, but m is smaller than n, so it's a fraction. So this might end up giving you 0. Let's see. Yeah, it gives you a 0. And now you might be wondering like, why is it a 0? It's just a very simple logic. When you take an integer, you divide by an integer. Of course, from mathematics, you find that you'll find maybe it's a decimal point of maybe 0 point something. But now, when you divide two integers, C++ will still give you the result as an integer. So when you take the answer as 0.9 something, then the integer of 0.90 is still 0. The integer part is 0. That's why you see the output here as 0. So what you normally do, to be able to get a float here, you have to cast the values into floats. And a way to do them is that you can just write here float. This is a C way of doing casting, but C++ has a different syntax for doing casting. So, oh, sorry, I'm doing it in the wrong place. It should be here. It should be here. Yeah, so what I expect now is to get the floating point answer, which is 0.625. That's now okay. So when you divide an integer with an integer, the result will always be an integer. So to be able to get a float, you have to cast those values. So you have to know that in C++ and C. That's usually the rule. Because sometimes you find that you'll be writing a code and you'll be wondering why you're getting zeros or you're getting just whole numbers. Always check your variables. Alternative to this, you'll just have to define these values here as float or double. Float, as I mentioned earlier, floating points are just data types which have a floating point. They have a dot point something. So if we run this as well, we expect to have the same output, which is a floating point. Oh, sorry, I still have to cast them here. Yeah. Anyway, you're oh, sorry, I think I've done it on the wrong side. It should be here. Yeah, that's why we're still getting a 0. Yeah, it's now okay. So when you're dividing a floating point by a floating point, then the result is still a floating point. That's why it gives you a 0.625. So let's do here a multiplication. I'm going to return this to an integer because this is supposed to be an integer as well. Let me expand this section at least so you can be able to see it better. So, sorry. It's supposed to be more times. Yeah, if you have any question, just you can go to, I'll respond to them just in a short while. We're just winding up this session. 8 times 5, of course, is 40, so that's okay. So, multiplication, division, addition, subtraction, those you can able to do them. The one last thing I want to show is the remainder part, where usually this, I want now to take the bigger number by divided by a smaller number. So I want to get the remainder after division. That's how we usually use this percentage sign to show the remainder. So if you're dividing like 3 by 2, it gives you a fraction. So what's this value remaining that ends up giving us a fraction? That's what now we're trying to get now when you're using this operator called percentage. That should be n. Let me just move this part. Let me just leave it like that. There's nothing else. I'm just displaying that. So what do you expect here? You divide 8 by 5 is 1, and the remainder is 3, of course. So the output is 3. So those 5 things, the addition, subtraction, multiplication, division, and the remainder, you'll be using them in most of the algorithms you'll be dealing with in C++, any functionality. So you need to be well versed with them, understand them very well, because you will find them a lot. So let's look at the last thing. I want us to look at the user input. So I want to get some values from the user. We have defined a value here called m, which is 5. So let's get a user input and assign it to 5. And for this class, I'm going to assume that the user is going only to input integer types, although in real production world, users type in anything. So you have to be able to um, catch all the errors which might arise from the user input. User can be able to key in an empty string, gives you a letter of M and you're expecting an integer. So you should be able to be prepared to be able to catch any error that may occur during these sessions. So let's just say usually if you want to get the user input, you have to prompt the user for with some information, so the user can be able to know like, oh, I'm supposed to enter something. So let's ask the user to enter their age. So I just do a cout. Cout is just, as I mentioned earlier, just piping everything out to the output just to display them. So I'm going to do a cout. Let's just say, let's use the mangoes. Let's just hear how many mangoes we have. So I'm not going to terminate by a new line because I want the user to enter a number there. So then I'll just do cin. This was cout, which is the console out, and now this is the cin, means that you're getting data in from the console. So to print the data to the standard output, you're using the two angle brackets. But now to get the data and send it to a variable, you're using the opposite of it, which is now the two for the greater angle brackets. No angle brackets, it's just called the greater than size of them. Sorry. So you do like that, then you assign it to, let's say, mangoes, because you have the mangoes variable up there. Then we shall just do a printing of how many mangoes do you have so far. So I'll just do, we now have how many mangoes? Yep, mangoes. And I just do mangoes. New line, and then I end with a semicolon. Because this is the last thing we shall be doing, then I'll respond to your questions because I'm seeing it's time is much gone. So you can see how many mangoes do you have. So let's type in a number, let's say 78, and I click enter. You see, we now have 78 mangoes. So something you have to keep in question is that the values from the user usually comes as string. So if you want to add a number into now this value of mangoes, you have first to, by default, because I define mangoes as an integer, it will cast it into an integer. But when you be dealing with user input, everything coming in is a string, so you need to do your casting from one type to another. Casting is basically converting from one data type to another one. So if I have an integer, but I want to work with it as a float, I'll cast my integer to a float. So if my integer was 5, then the casted value of 5 in float is just be 5.0. And I can still cast it from 5.0 back to 5 by casting it back into an integer. So this is just the basics of C++, how to define variables, how to do basic manipulation of the variables, displaying the console, getting the user input, and just understanding how to do your documentation in your code using comments. So this is just the basics. We're just laying down the ground, and now the heavy part will now begin next week during the next sessions, when we shall be doing things like syntax, sorry, not syntax, it's not called conditionals, looping, functions. So currently, today we're just working with the main function alone. But you see, in your program, you will not write all your code inside the main function. You might be having a function which will now be displaying the data, another function which will be maybe getting the user input, another function to do the processing. So you may be having a lot of different functionalities. And so to be able to achieve this, you need to have a structure of function A, function B, function C, function D. So in the next session, we shall be talking about how to write your functions and how to be able to link them together inside your main file, so that when the application entry has begun, we can be able to call those functions, get pass data to them, and get the data back from them. That's one of the most key areas. And then once we understand functions and the conditionals as well as the loops, In the other session, we shall be able to look at the heavy part where everyone sometimes fears, which is the object-oriented programming that's using classes and objects, as well as structures a bit. So today you'll be able to look at these, the basics. You are just doing the groundwork, laying down the ground. And you can be able to find today's source code on this GitHub repo. This is my GitHub repo. Just search for minus KE on GitHub, you'll find me. You'll find this repo called IKU beginning C++. So that repository will show you some guidelines on what you do require. Let me show you. This is it. This is the link I've just sent you. And here will just be a basic description of the kind of IDEs we have. And if you just click on any of these links, it will take you to the download page of those platforms. This is the basic example I've been doing so far, but with some other explanation. And basically, from today's workshop, this day was workshop 1. So we have a folder called workshop 1. If you come to workshop 1, you can go to get what you've done today so far. And you'll find I'm in the CPP file what we have been working on today currently. So if you just search for me like -ke or just click the link which I've shown you, you'll be able to get my repository, click on it, learn. If you have any issue, can be able to just tell me and I can be able to respond to it. So with that, I want to say thank you for being good listeners, being a good audience. So but still follow us on Twitter. If you have any question, you can still drop them. This is my handle, the first one. The rest are for IEEE KU, different societies. You can drop us any question you have. If you have any challenge, you can be able to respond to any query. This is my handle personal. So with that, I'll hand over back to Mercy. Thank you.
Wow, thank you so much.
Thank you so much. Thank you so much.
Thank you so much, Alan, for the wonderful and amazing presentation. I have indeed learned a lot. Wow, I can't even tell how much I've learned, but I just know I've learned a lot. And thank you so much. Now we're going to go through I'm going to read out a few questions that have been sent on the chat box. So a question by Ronnie Leon is saying, using stdc out is more advantageous than using namespace. Could you elaborate on this? This is a question by Leon Ronnie. Maybe Alan, are you going to answer them at once, or are you going to answer like one question at a time?
Let me just respond them one at a time, and see how I might end up skipping some questions. Leon, that's true. Let me, as I mentioned earlier, we are currently just working with the standard library here. But now there are many other C++ libraries which have different implementation of different functionalities. For instance, if you want today to do some string manipulation, you want to split them, the standard library does not offer directly such functionality. But libraries like Boost do so. So imagine that you have included here hash include Boost. Of course, to be Boost. Of course, this I'm not sure if this is not installed here, but I'm just showing an example. Then I'll do Boost .h. This is just an example. I'm not saying it's written like this, but we have a Boost library for which they have different very nice functionality added into the standard library. But now you see these two libraries have same implementation maybe of a string, of an integer, so they'll be clashing. What normally happens is that if you're now writing and you're utilizing more than one library, so it's usually advantageous not to use this using namespace standard. It's normally advised that you have them here. So here I'll just do a standard names, standard C out, because I'm sure that I'm using now the standard library for this particular purpose. Maybe in my next case, I'll not be wanting to use standard C out, but if I've defined here on top here as standard names using namespace standard, then by default, the compiler assumes like everything that comes just the standard. It's just the standard library functions unless specified. So I've worked with many big libraries like Qt and things like those, and you see they have different implementation for some of the same functionalities. Like they have the same names but different functionalities. So it's always good to use STD where you want to use them. Like if you want to do a C out here, you just use standard C out. And the biggest area of this is using strings. Because that's where I know I've faced a lot of issues because if you want to you write a string like say my name, but now many libraries implement the data type string. And if you just import it into a library, and if you're using the standard, using namespace standard, if you fail to specify here that you're using a namespace called, let's say, name X, which I don't know, if you fail to do like that, then by default, this is assumed to be the default namespace, and it might give you the different response from what you're expecting. Maybe you're expecting to maybe split a string, but an error occurs. This cannot be done. Whatever you're trying to do does not exist. The functionality you're trying to access does not exist. So it's usually advised if you're importing many different packages, libraries, then just use this functionality where you need it. Or alternatively, you can just use the standard namespace up here. But for any other library that you're now importing, use their namespace whenever you need them now specifically. Yeah.
Thank you, Alan, for the response. Ron, gotten the answer you're looking for. So the next question is from Jeff Ayako. Jeff is saying rather you talked of speed performance optimization. How do you test your code to see the running time? That's a question from Jeff.
There are many ways, Jeff, to do that. First, there are tools online to do that. We usually call them benchmarking tools. So you just make your code or you make an application, then you run them in those benchmarking tools. They usually tell you how long it takes to run, and that's why what people normally use to test big programs. Or normally hear someone telling you that language X is faster than language Y. Why are they saying that? There's a sample code which they used, and they were testing to some limit. So normally use just look Google online for benchmarking tools for programming. You'll find a lot of them. If you just want to measure the time, then you have a library in C++ called Chrono. And let me just show you. It's called Chrono. I'm not going to write any code. It's called Chrono. It's used to measure time using ticks, usually very accurate. So you can go to maybe insert chrono before you start a function and maybe check the current time after the function, then you do the subtraction. If you just want to check the time. But if you want to do a real benchmark, then there are very many tools out there. Just Google one and use any of them. All of them offer different functionalities, so you need just to know what are you trying to measure in your application. Yeah.
The other question from Jeff. Jeff is asking, what is the difference between enum and data type in CPP? And maybe to just add in another question, is also asking, is unpacking of variables in CPP possible coming from Python background?
Hmm. Um. Maybe. I know a bit of Python, but I'm not that good. So I've heard that term unpacking variables, but I'm not sure what it means. Unless if it means where you can instantiate. Jeff, I'm not sure what you mean, but if you mean this, like this syntax of Python whereby you do x, y is equals to 2315, maybe like that, then I don't think I do this in C++. Currently, I know I don't think so. Unless if someone knows it can be done, you can go to inform me. But from my knowledge, I don't think that's possible. Then from your first question, you said about enum. Enumerate data types. These are normally used for user-defined when you're not defining your own data types. So we want to know the difference between enum and const data in CPP. Const data basically tells you that you can't change it. So for instance, if you define your variable age here as constant, as const, something like this, we're saying that all these variables here are constants. They can't be changed. And so if you're declaring a variable as constant, you have to instantiate it as well. That was very hard. So you have to also say this is 5, of course, and this is 7. So you have to give it a value. And during the lifetime of that variable, you can't be able to assign it to a new value. So because it's a constant. But enum types are used for instance, you have a number of things you want to be able to reference to one of them. It's just like, I don't know how to explain this. I don't want to code now. Um, enums normally, for instance, you have a color, you have a variable called color. But in this world, we have many colors. So this enumerator type will hold the different colors inside this variable. And then you can be able to access them using either an index which you specify or something like that. Because when you're defining enums, you will say maybe the first item will be called number 10. And so you'll be able to access the enum number 10, and that's color, the specific color. And maybe it's incrementing or something like that, or decrementing, depending on how you now implement it. So enum is just used for encapsulating similar things into one variable, something like that. Yeah. So there are two different things. Const means you can't change it. Yeah.
I think you response. Jeff, I hope you're satisfied with the response. Jeff also has an why is memory management is of fun unlike in JS or Python?
Okay. Let me respond to that. I'm trying to find the best term to use. Yeah, I've got it. Python and JavaScript, even Java, they have something called a garbage collector. Just think of it. What's a garbage collector? Anyway, just normal terms. It's just something that just comes in to collect someone who maybe a truck or something that just comes in to collect all the unwanted garbage. So what is referred to as garbage is that every variable in your code has a lifetime. That means, sorry, when it goes out of scope, then it's no longer required because its lifetime has expired. So in these languages, these things are automatically garbage collected by the garbage collectors. So these things have been already built into those languages. So how those garbage collectors work is that you run your application when it reaches somewhere when maybe memory has reached somewhere or execution has reached some level. Then the garbage collector comes in. It's kind of like everything is stopped first. It goes in, checks for all those memory variables which are no longer those which their what do you call their lifetime has expired or they're out of scope. It now clears that memory to be used for allocation of new variables. But when you come to C and C++, you find that the allocation of memory, if you're pushing anything into stack using the new pointer or malloc, then you have to deallocate it yourself. Failure to do so means that that variable occupies space and no one is going to use it ever again in your code. Because if you try again to run the code again to create a new memory, it will assign a new memory location to that variable again. And if you fail to deallocate, it contains, and a mistake most people normally do is that you're assigning memory in maybe a loop. You find that you're assigning a memory, you don't deallocate. In the next iteration of the loop, you're assigning a new memory location, you don't deallocate. So you find that in just a short span of time, you find your application has consumed 1 GB of storage, and you wonder like how comes. So when people normally tell you C and C++, you have to manage your own memory. That's what they normally mean. You handle the allocation of memory, you handle the allocation of memory. If you fail to do the allocation, then you know the application is really going to eat a lot of space and end up even sometimes find that the application just tells you it's out of memory because it has consumed all the available space for the code. Yeah.
Um, Thank you, Alan, for the question. Jeff, I hope you've gotten the answers to the questions that you're looking for. And so to the last question, the last question is from Stephen Okola from Vitals, saying, "Can I kindly get an assistance in learning smartphone game development, since I'm a novice in the tech industry?" You say, "I have not studied any tech related course." Thanks for him.
Um, Steven, I'll have an advice for you that it now depends on how you want to approach it, but developing games for smartphones, then there are many approaches. There are many what do you call them, engines for making those games. But the two best which I know is Unity 3D and Unreal Engine. So depending on the path you want to use, Unity 3D is one of the best. It's actually open source, and that's one of the which is used to making games like can I remember? I think Angry Birds, but I'm not sure. You can confirm that, and I'm sure about Pokemon Go. That's being used. Unity is used to making them, as well as there are very many big games which they usually made in Unity. Although Unity now you have to program in either C sharp. C sharp is C hash. C sharp is not something. It's just another language developed by Microsoft. Um, or JavaScript, but I'm not sure about JavaScript. You can confirm those as well. The second option is second best option actually is Unreal Engine. So with Unreal Engine, you can be able to use C++ to do programming. They normally say it's a bit beginner friendly, but I've never tried it. I've never tried any gaming stuff. So maybe look into Unity. You see the kind of things they're doing. You see if you kind of like that. Or you also look into Unreal Engine. Unreal just for Unreal, Unreal Engine. Another thing I'd advise you to maybe learn is how to develop 3D models. Softwares like Autodesk Maya or even it's an open source one. It's called Blender 3D. So these softwares will help you maybe making those game characters, things like that. You can then export those models to be able to use them to make your games. So Steve, you want to venture into that side, look into the two I've mentioned, and then also look into how to design 3D models using either Blender or Autodesk Maya, whichever you find the best. But it's important you also learn how to do those 3D stuff because you don't wanna need it much when you'll be doing now the rendering side on the Unreal Engine or on the Unity 3D. Yeah.
You so much. And that was the end of the questions. Thank you so much once more. Uh, Amazing session, an amazing workshop. Learn about how we can use C++, its application, everything that you've learned to see. Thank you. And also just to thank the audience, Jeff, for the questions. Anyone who participated, thank you so much. Thank you so much for participating. And um, I believe this will happen again next week on Friday. So stay tuned and see you. And before that, I think we have a survey. Alan, do you have a survey?
Yes, yes, yes. Just a moment. Let me send it to the chat section.
Um,
Just a moment.
let's fill it and yeah, let's give of the workshop.
For those who registered for the event, there is a survey link on that registration form. Because I can't access my WhatsApp right now. Yeah, it's there on the chat section. I've sent it.
Yeah, you've seen it. Let's fill the form and feedbacks. And it's about IEEE. If you're IEEE or you're a member or you have not renewed your membership, please do so. At the moment, I believe it's half the price. It's normally $27, but right now it's half, maybe 1,600 Kenyan shillings. So let's do this and join IEEE. Let's volunteer and network and develop ourselves. Yes, I believe with that. I'll say again, thank you guys for joining the meeting. Thank you for being an amazing audience, and we're looking forward to seeing you next week, the same time, the same. Yes, notices. Anyway, thank you and have a lovely evening.
Thank you.
Your own flavor.